Welcome back. AsyncIO provides us more options. Let's modify our use case a bit. So the first 2 points here are the same as before. We have to scrap data from 3 websites, and data from these websites can be scrapped independent of each other. Additionally, after data retrieval, we want to merge analytics data from each website. And if one of the tasks fails, it makes sense to cancel the rest of the tasks. This is because if we have partial data, it doesn't make sense to move ahead to merging that partial data. So it makes sense to cancel the task. And with such kind of requirements, AsyncIO provides us, starting Python 3.11, a new feature of task groups. So we will implement this starting with the same code that we implemented. Let's paste it here. So we have the same coroutines, and in the main function, we have to make changes here. First, we have to use the task group context manager, async with AsyncIO dot task group as TG. Now we can create these tasks as part of this task group. All right, so we can remove this. And now we also want to collect the results. So we need to replace this. But before that, we need some way to reference the tasks after the task group context manager exits. So we take tasks list again, and we can append each of these tasks to this list. All right. Now we can reference these tasks with this tasks list. Yeah, we can remove this also, and we have to replace this one for task in tasks. We need to await the task so that we can retrieve the result on its completion, and we can, for now, we can print it. Otherwise, we can use it as we want. Let's execute this. Before that, let me clear this terminal. So once again, we have executed all the tasks concurrently, this time with the task group. And we have the results here. And once again, it executed in 0.9 seconds, which is again the time of the longest running coroutine, not the sum of all those coroutines. So we are still getting the concurrency benefits. Now the new requirement, that is, if one task fails, we have to cancel the rest of the tasks. In fact, this functionality is provided out of the box by Task Group Context Manager. So if an error is raised by one of the coroutines, the rest of the coroutines or the tasks will be cancelled, and the context manager will raise a cancelled error. We need to handle the cancelled error in each of the coroutines. So try and accept AsyncIO.cancelled_error, and we print here that this coroutine is handling the cancellation grace. And actually we can perform here whatever it needs to gracefully handle the cancellation. Let's add here website 1 so that we can identify which of the coroutine is sending us this message. We have to accept the exception in the coroutines for website 2 and 3 also. This one is for website 2 and here as well. And this is website 3. All right, so we have handled the errors here, and we also need to handle the error. So first, let's raise the error. Let's say in the website 3, a value error occurs during the execution, and now we have to handle the value error here. So we close all of this in try block, except this can raise multiple exceptions. So except star value error, and we print so yeah, we have the setup ready, and we can now execute. So we can see that all of the 3 coroutines started concurrently. Website 2 was already done before website 3 raised the value error, and website 1 was still running, so cancelled error was sent by the context manager to the coroutine for website 1, and it handled the cancellation gracefully. And lastly, we are getting this message, which is from the main routine where we handled the value error exception. And now the total time of execution has reduced to 0.6 seconds because one of the coroutine didn't complete. So we have actually saved the time in case of error. I want to show you one last thing with the concurrent execution of tasks. There is one more feature that is provided by Python's AsyncIO module. If we look at these coroutines, they complete in different amount of times. This one takes 0.9 second, this one takes 0.5 second, and this one takes 0.6 seconds. Gather and task group, they both allow us to process the results after the completion of all of the tasks. So they handle the tasks as a batch. So once whole of the batch is completed with the processing or execution, then we can handle the results. But let's take another modified case. So starting with the same use case of data scraping, we have new requirement to process the data of a website as soon as that data is available without waiting for the rest of the batch to complete. To do that, let's start with the same code that we did with gather function. I'm pasting it here. So we have the same coroutines again, and we can actually keep this because we need the tasks again, and we can replace this part. So we'll have a for loop and for a task in AsyncIO dot as completed, and we pass in the list of tasks, and let's call this completed task, and then we can await the completed task to retrieve the result of this single task, and we can print the result. So yeah, this as completed function takes the list of the tasks and returns as soon as the task one of the tasks is completed, and we are then awaiting it to collect the results, and we are printing it. Let's run this one, and now we see that all of the tasks started concurrently, and as soon as one of the coroutine or the task completed execution, we get its result. So website 2 is the fastest to complete. It completes in 0.5 seconds. Then website 3 is second one, and website 1 takes the longest time, 0.9 seconds, and the overall execution time of the program stays the same, 0.9 seconds, the longest coroutine time. So that's all for today, and this also ends the module 2 of this AsyncIO course. All the content related to this session is also available in text form on my website atifazad.com. The article link is available in the video description. If you are interested, you can also find the related code in my GitHub repo. I hope you enjoyed the session today. Thank you for being with me, and I look forward to see you in the third module of FastAPI-AsyncIO Foundation course.